Good evening, all. In the last lecture, we have seen the Z transform of a discrete signal, right? What is Z transform and basics of that we had seen. Now we are going to see some of the standard signals, Z transform of that, and some properties of Z transform. So before that, we'll just revise what is Z transform, right? So X of Z when you are writing, right, that means you are signaling Z domain, that is Z transform of X of t, where t is the continuous function, correct? Then that is equal to summation of k equal to 0 to infinity x of k z raised to minus k. Okay, so this is the definition of Z transform. That means any signal, whenever it is given to you, that particular signal, for those many instances, you are supposed to sum up by multiplying it with Z raised to minus k. So don't forget this. This is very important for you. Then the next thing is now the fifth point. If you can recollect, in the last lecture we covered 4 points. This is fifth point now. That is Z transform of summation of standard discrete signals or standard digital signals. Both the things are same. And number one of that, let us say I'll mention it A, the unit impulse function. Or okay, fine. Function. Unit impulse signal also you can say, or unit impulse function. Okay, impulse function you know, and unit impulse also you know. All these signals already I have explained you. Normally you denote it by delta. So it is delta k. Whenever you are writing a square bracket, that is telling you that at kth instant what is value of the function. So we know that it is equal to 1 when k is equal to 0. Right, at initial stage, and it is equal to 0 when your k is not equal to 0. That means k delta 0 is actually 1. Okay, now delta z, whenever you will be in time domain, we are representing it by delta, by this delta small 1, and capital 1 when you are in z domain. So z, delta z is equal to, we are going by the definition, summation k equal to 0 to infinity delta k, because your signal is this now, and instead of sk it is actually delta k z raised to minus k. Correct? Now if we will expand this, you are going to have delta 0 z raised to 0, correct, plus delta 1 z raised to minus 1, plus delta 2 z raised to minus 2, and will continue. So delta 0, we know that at initial condition it is 1, z raised to 1 is also 1, rest all are 0, correct? That means 1 plus 0, 0, 0, that is going to give you that, yes, delta z is equal to 1. First function we have done. Now we'll go for the second one. Just give me 1 minute. Yeah. Now I'm talking about the second one, B. That is a unit step function or unit step signal. Now you know unit step function means from 0 to greater than that it is going to be equal to 1. So I'll write u of k is equal to 1 for all those k's which are greater than or equal to 0, and it is going to be equal to 0 for all k less than 0. And now we want to know what will be the z transform of this, and I am writing on this side. So small one, right? In capital we used to write it as gamma. So gamma z domain we are representing it by gamma. We'll go by the definition, summation k equal to 0 to infinity, right? uk z raised to minus k. Okay, so now uk, you know it is 1 because we are starting at 0, so it is going to be equal to k equal to 0 to infinity. Value of this is 1 for all k greater than 0, so it will be just z raised to minus k. Now summation of a series, right? This is becoming a geometric series. If I'll write this as k equal to 0 to infinity z raised to minus 1 raised to k, and you have studied this, right? Any geometric series you can write its final value as, I'll write using formula for geometric series. Okay, it gives I'll just write the formula in word. Total summation is equal to first term divided by first term divided by one minus common ratio. So now in this case, if you apply, you are going to get gamma z is equal to, now just observe first term, k raised to 0. So anything raised to 0 is going to be 1. So first term is 1 divided by 1 minus. Now the common ratio what you are going to have, z raised to minus 1 raised to 1, z raised to minus 1 raised to 2. So common ratio is z raised to minus 1. So if I simplify this, right, it is going to be 1 upon z. Z will go in the numerator. It is going to be z upon 1 minus z. Z minus 1. So this is first step function. Now I am going for the third one, CLC. And third one is the exponential function. Okay, now when we are talking about exponential function, e raised to something, or we can say a raised to something, some constant raised to something. So both the things are possible, right? So we'll take both the cases. Number one, when you are saying f of k is equal to a raised to k, when you are having k greater than or equal to 0 and is equal to 0, इसको बोलते हैं one sided signal. No, it is not double sided, because on negative side we are not considering the signal, we are considering initial condition to be equal to 0, k less than 0. Okay, just a minute. Yeah, so in this case now, if you are writing f of z, function is small f, so in z domain we are going to write f of z. right? F of z will be what? Summation of k equal to 0 to infinity a raised to k z raised to minus k. Your function f of k, right, or your xk we can say, is your a raised to k now. So if you'll write first term, okay, I'll just write it like this, so will be more easy for us to understand. A z raised to minus 1 raised to k, right? In the same format we are trying to put it, and if you'll apply again the formula, you are going to get f of z is equal to 1 upon 1 upon, right, 1 minus, because see, when it is 0, anything raised to 0 is 1, so your first term is going to be this, and the common ratio will be this thing, because every time the power will get changed, 1 2 3 4, the common ratio will be a z raised to minus 1, correct? So if I'll simplify, this is going to be upon z, and it will be z upon z minus k. Just z minus a, sorry. This is going to be for the exponential function. So I'll make bracket for this. Right? Second case, when you are having e raised to something. So I'll write that. I think now you will be able to write the thing directly also. Let me write it first and think of this, whether you can write it directly. E raised to minus a k t. Okay. When k is greater than or equal to 0, and this is equal to 0 when k is less than 0. Okay. So how I can write this now? F of z is equal to summation k equal to 0 to infinity e raised to minus a kt into z raised to minus k. So how we can write this? Summation k is equal to 0 to infinity. Now we want that k to be in the, power of all this. So what we can say? E raised to minus 80 z raised to minus 1 raised to k. Again you go by the geometric series, and you are going to have f of z is equal to 1, because initially 1, right, divided by 1 minus the common ratio you are having is this thing, that is e raised to minus 80 and z raised to minus 1. So if you want to write the, just a minute, I'll make a partition. Yeah. So if you want to simplify this, you are going to have f of z is equal to z in the denominator, take it over here, and here z upon z minus e raised to minus 80. Right? So we had seen 3 signals for which you can have z transform. These are the standard signals. Now one more, last one, that is cosine function. So I'll write it over here, d. Just a minute. That is cos function. So f of k is equal to cos, let us say ak, I'll put bracket for that, where k is greater than or equal to 0 and is equal to 0 when k is less than 0. Fine. Now we want to represent this. See, e raised to I theta, correct? If you want to represent it in sine and cosine, it is cos theta plus I sin theta. On the same line, if you are writing e raised to minus I theta, correct? Basme, you might have done this. Cos of theta minus I sin of theta. Now if I'll add these two, I'll have the cos function, so I'm adding. So 2 cos of theta is equal to e raised to I theta plus e raised to I minus I theta, correct? So if I want to write this cos theta, how I'll write? Cos theta is equal to half e raised to theta, I'll put bracket for this, plus e raised to minus I theta. Okay, this is the formula which we'll use for solving this function or getting Z transform rather for this function. Just a minute. Yeah. So now whatever function that we are having, I want to write it in these terms because it will get converted into the exponential term and will be easy for us to write the Z transform of this, right? So I'll write f of k is equal to cos of ak is equal to half e raised to I ak. I should put the bracket, correct? Or rather, because we talk about this thing, control, right? We should use j. So I'll make that change. Wait. Half inside the bracket e raised to jak plus e raised to minus jak. And now we'll open these brackets and we'll try to find out what is the Z transform of this. Okay. Just a minute. Yeah. So we'll go for that Z transform. Now I'll write f of z. It was cos of, again I'll write that function, cos of ak is equal to half inside the bracket e raised to jak, right, plus e raised to minus jak. Now we are going to take Z transform on this. Definitely we have to take on this side also. So I'll write f of z. And no need to write cos and all those things. This is your f of t. Your f of t is equal to this. So I'll write f of z will be equal to Z transform of half inside the bracket e raised to jak plus e raised to minus jak. So we'll open the brackets and Z transform we can distribute over addition. So we'll have half inside the bracket, right, Z transform of e raised to jak plus Z transform of e raised to minus jak, and we had seen what is that Z transform, right? So I'll use that previous formula and we are going to have half, right? What the formula was saying? Z upon, just a minute. Z upon Z minus e raised to ja, correct? And plus for this Z upon Z minus e raised to minus ja. Correct? So what we'll do is, first we want to rationalize this because we want denominator to be same. So we'll multiply it. I'll multiply, just see whether you are able to understand the thing or not. Just a minute. Yeah. So Z, now by this complex conjugate of this, no, we will not multiply by the complex conjugate, we will multiply by this term, so that as if we are doing cross multiplication. So Z minus e raised to minus ja plus z minus e raised to ja, whole thing divided by multiplication of these two terms, that is z minus e raised to ja, z minus e raised to minus ja. So we'll open the brackets and we'll try to see whether we can have something common or anything else we can cancel out. So let us see. So half okay, you can see over here z square and z square twice, so I'll write 2z square, right, minus, both the terms are having minus sign, so I'm taking common, z e raised to minus ja plus z e raised to minus plus ja upon now expansion of this. So you are going to have z square minus z e ja minus z e minus ja, right, plus, when these two terms will get multiplied, they will cancel each other. Cancel means 1 upon reciprocal of that, so it is going to be equal to 1. Correct? So what we can write now, half inside the bracket 2z square. Correct? Now see, just observe this, we had written the formula, right, over here. So what it is going to give me, minus z is common, so z twice, correct, on this side it is going cos of a, because this term, right, cos of a, now this ja is there, so k ka value is 1 actually, correct, divided by k is not there, rather z square. Again, if you take minus, the same term you are getting, minus z2 cos a and plus 1 previous one. Okay? Yeah. Still, if you want to write in simplified format, because this 2 we can take it out and we can have we can cancel it with that half. So you will have z minus cos a. Correct? This 2 gone, this z gone, divided by z square minus 2z cos a plus 1. This is your f of z, or z transform of a cosine function. Okay, fine. Now we'll go for some of the properties of this Z transform. First we'll try to understand the properties and then we'll go for solving the numericals, right, based on the Z transform. Okay. So 6th point, properties of of Z transform. Okay, so first property, very simple one. Actually, we already used it while solving this, right? Z transform you can distribute over addition. That is called as linearity. Okay, so I'll write. So number one is linearity. See, if we know all these properties, then only it will be possible for us to solve the numericals, because all the properties should be known. Like for the Laplace transform also some properties were there, right? You already learned that. That's why we had not discussed while solving the numericals in Laplace domain. But definitely we should learn those things, those properties for Z transform. So what Z transform says, if you are having addition of two functions, let us say a x1 n plus b x2 n. Okay, that will be equal to a is constant, x1 n ka z transform, that you can write it as x1 z plus b x2 z. Okay, then the second property, I'll write a, so will be easy for us to differentiate between the numbers, bigger one and smaller one. So this is a, first property. Then second one is b, and b is time delay. Okay, now time delay, we can say one more word to that, time shift towards right or to the right. Okay, so I'll not draw everything, just listen. If you are having this instance as 0th, first, second, third, fourth, and they are having some values, let us say these are the values of these instances. Okay, and you are talking about shifting towards right. That means introducing delay in the system, right, after some time. So let us say after 3 instances, now you are shifting your signal. That means how it will look like: 0, 1, 2, 3, 4, 5, 6, right? So 0, 1, 2. Now this 0 signal will come over here. So I'll try to draw. Okay, should I draw it in fair? That will be better. You will have the data also instead of rubbing it afterwards. Within some amount of time, I'll draw it. So let us say this is your magnitude and this is the time axis. And now you are shifting it. So shift ka plot. Yeah. So see, let us say this is your 0th instance. 3, 2, 1 and 4. Okay, so this is your signal. This is 0th instance, first, second and third, and now you are talking about shifting it by 3 places on the right hand side. So now what is going to happen? 0, 1, 2, 3. Correct. If you are shifting it by 3, 4, 5, 6. Now what is going to happen? This signal will be your third instance. So I'll draw. Then first is 1. So your fourth will be 1. Second, 2. Sorry, 1. 1. Length is 1. And again length is 2. So this is called as right shift. Now on the waveform, yes, you understood. Should I write the axis? Time, right? Or you can write T also, fine. T will be better actually. And this is also T, and this is some magnitude. Signal I'll write. So now if you are shifting any signal towards the right, that means you are introducing lag in the system. Okay, then how my system, what is the equation of that? We are trying to see that. Okay, so I'll write Z transform of X K minus 3. Do you agree? When you are shifting on this side, after some time the signal is going to come. That means you are introducing delay of 3. So should be represented as K minus 3. Correct. So this K minus 3 will be equal to summation of K equal to 0 to infinity X K minus 3 Z raised to minus K. Now very well it is understood that even if you are saying K equal to 0, actually for all these instances your signal is becoming 0. So first 3 bit, because they are becoming 0, definitely I can write summation K equal to 3 to infinity X K minus 3 Z raised to minus K. Okay. Correct. Now what we want to do, we don't want this. We want, whenever you want to represent Z into in terms of Z, I should have 0 over here. So we'll try to just replace this thing by something. So just a minute. Yeah. So see, now we'll say let K is equal to, or K minus 3 is equal to L. Right. So when K is equal to 0 or K is equal to 3 rather, L will be equal to 0. Fine. Right. So we'll put that value, and you are going to have that's equal to summation. When K is equal to 3, you are going to have L is equal to 0. That means L is equal to 0 to infinity. Right. X of L Z minus K. If it is minus K, then instead of minus K I can write minus 3 plus L is minus K, or I can write this thing as minus, if I take minus common, right, it is going to be L plus 3, correct? Sorry, 3 minus L. Agree? If you take minus sign common, it will be 3 minus L. So we'll try to substitute that. So you are going to have Z raised to, now Z raised to minus K is minus 3, or I'll put bracket, minus 3 minus L. Correct? So if I'll take this Z raised to minus 3 common out, you are going to have L is equal to 0 to infinity XL and Z raised to minus L. Just a minute, I made a mistake over here, right? I should write, this is my mistake. That's what I was thinking, why I'm not getting a plus sign over here. See, once again I'll repeat the thing. You are having this L, so if I'm writing minus K, then minus K, I will have minus 3 minus L. So I can write it as minus inside the bracket 3 plus L. Yeah, now it's correct. Okay, so that means Z raised to minus K means it is minus 3 plus L. Correct. So you are having minus 3, you have taken it out, Z raised to minus 3. So what remains? Z raised to minus L. Correct. So you can see for definition of your Z transform, it is that function Z raised to that variable instead of K. Now we used to write it in terms of K. We are saying the instances are named as L. So first instance, second instance, right? So K equal to 0, 1, 2, 3. Instead of that, L is equal to 0, 1, 2, 3. So what you are going to have now? Z raised to minus 3, and this is your x of Z. Yes. So keep in your mind, whenever you are shifting any signal towards right, so you are going to have the value of that is Z raised to that particular value multiplied by Z transform of that function. So if I want to generalize, Z transform of any function which is shifted by, let us say, n instances towards right, very important thing, then you are going to have Z raised to minus n, correct, and multiplied by Z transform of that function. Okay, so we'll go for the next property now, that is convolution. Now I know you don't know convolution, just I'm going to explain you what is convolution afterwards. Just try to understand the property now. जैसे होता है addition, subtraction, multiplication, division, on the same line the thing is convolution, the one more what we can say, operation, right? That is convolution. What is meaning of convolution? I'll tell. Have patience. Convolution. But how this property works on Z transform, that is our interest, right? So if I'm saying y of n, any function y, right, of n is equal to summation k equal to 0 to infinity, and it can be represented as multiplication of two things, that is xk h n k, n minus k. Now means what? I'll explain you. See, output is equal to इनपुट मल्टीप्लाइड बाय द ट्रांसफर फंक्शन. अभी ऐसे समझ के चलो ये सब क्या है मैं बताऊंगी. हैव पेशेंस, राइट. आउटपुट इज इक्वल टू इनपुट मल्टी, जैसे यू यूज्ड टू राइट नो, जी ऑफ एस is equal to C of S upon R of S in S domain, correct? So when you multiply these two things, correct, you are going to have your output. Now you cannot write this thing in T domain. You cannot write this, correct? You cannot multiply these two things, correct? When you are in frequency domain, then only you can do this on the same line. Now we are in time domain, so we are just cannot multiply, we are writing summation for that, and this whole function is actually the convolution. Whatever process that you can see over here, summation of k equal to 0 to infinity for all these, for these two functions, that is actually the convolution. Karte kaise convolution, I am going to explain you in detail in the next video, right? But if you'll find, if you are taking Laplace of this, one more way I'll try to explain you, try to tell you how it can be represented. The same thing you can represent it as xn. Convolution is represented by star hn. So how to do this, I'll explain you. Now time being, just remember that as soon as you will take Z transform of this, it becomes just a multiplication, same as that of your what happens in S domain. Time domain you cannot do multiplication. Time domain is also convolution, right? which is there in the Z domain also. But whenever you are in S domain, yes, you simply multiply these two on the same line. Whenever you are in Z domain, simply you multiply these two functions in Z domain. Done. What is this H? What all these things are? Definitely I'll explain you everything. Have patience. So this is about the convolution, right? So I'll go for the next property now. D. Yeah, that is time advance. Means you are shifting your signal. You are trying. We cannot say we are shifting the signal, but we are trying to think that if the signal is shifted on the left hand side, what is going to happen for the Z transform of that particular function. So it is called as, this a time delay tha, it is time advance. And time advance means shift to left. Shift the signal to left. Okay. So let us say again we'll shift it by 3 signals. Should I draw it or is it okay? Just shifting it on the left hand side, right? So let me write it. Let us say Z transform of, you want x k plus 3 on the left hand side, means you are preponing it. So definitely it will be a plus, right? So how I can write this? Yes, summation of k equal to 0 to infinity x k plus 3, correct, z raised to minus k. Okay, now let k plus 3 is equal to L. So what I can write for minus k? Minus k will be 3 minus L. Okay. So what I can write for this? Z x k plus 3 is equal to summation. Now k equal to 0. When k equal to 0, L will be equal to 3. So L equal to 3 to infinity x L. Correct? You just concentrate on this. And z raised to minus k, that means z raised to 3 minus L. Correct? We have substituted. Now this thing we can write it as, see, you can see z raised to 3. So z raised to 3 I'll take common. So you are going to have summation L is equal to 3 to infinity x L z raised to minus L. Now this thing is in the Z transform ka format, but the problem is it is not starting with 0. So definitely we'll try to add some terms and we'll subtract terms, some terms. So you will find that yes, that will be beneficial. So what we should add? C is equal to Z cube, your original thing, L equal to 3 to infinity XL, sorry, Z raised to minus L. Now what do we want? We want the signal to start at 0. So I'll say L equal to 0 to 2 XL Z raised to minus L. Correct? Now you have added this term, so you have to subtract this term. Sorry. Correct? So you will say L equal to 0 to 2 XL Z raised to minus L. Yeah. So see, now if I write Z cube, now this whole thing will become summation L equal to 0 to infinity XL Z raised to minus L minus, see first term now, L equal to 0. L equal to 0, when you are having anything raised to 0 will be 1, correct? And it will be x0. So you are going to have x0 minus. Now see, when you will have L equal to 1, so it will be L equal to Z raised to minus 1. So I'll write Z raised to minus 1 x of 1. Correct? Now the next term, that is L equal to 2 till this. So it will be Z raised to minus 2 and this will be x2. Correct? So if I'll expand this now, what will have? Z cube. Do you agree it is xz? Right? And minus, now z cube say we have to multiply this term, so it will become z cube x of 0. Z cube means minus z square x1. Sorry, this should not be capital now. That is just an instantaneous value. It should be small only. Why to write capital? Yeah, x of 0. Then z square, that means just z, x raised to 2. Okay, this is what? Z transform of x k plus 3. How you are writing? Z square xz minus z cube x0 minus z square x1 minus z x2. On the same line, assume karo you have to write x k plus 2. So what will write? Oh, I made a mistake. It should be cube. Cube है ना? It should be cube है ना? So now square 2 से shift है, so it will be z square xz z square x0 z x1. Correct? If you are shifting just by 1, then you will write z xz z x0. Done. So this is about shifting on the left hand side. Okay, so we'll try to complete two, 3 more properties and then we'll stop, right? So multiplication by exponential. So D, I'll write E. Wait. Multiplication by exponential term, right? That means, for example, you want to find out z transform of, normally what we do, we want to find out for this, correct? Any signal, but the signal is getting multiplied by some exponential term. Then what it should be? So we know the formula, summation of k equal to 0 to infinity, your ak minus k, your signal, and z raised to minus k. This is by the definition, correct? So if I want to write this, what will write? Summation k equal to 0 to infinity, right? Your signal x k, and now instead of z, what we are having? Az raised to minus k, correct? So very simple, we can write it as z transform by multiplying the signal by a raised to k, any exponential term, right? Then you are going to have that thing to be equal to, very easy to understand, x of az. या ठीक है. So this is property number 5 for exponential. Yeah, we'll do 2 more and we'll stop. Now I'll write F, sixth one. That is differentiation. Differentiation property. Okay, now in differentiation, the statement I'll write first because that is very important, and then we'll see what is proof for that. The statement says Z transform of any series or signal xn, right, is equal to, we said, xz, correct. Then if you are taking Z transform of nxn, correct, so that is going to be minus z d dz of your Z transform of that particular function. Okay, right. Whenever it is variable, we represent it by small. Whenever you are taking Z transform, that should be represented by capital Z. जैसे Laplace transform में you represent it by capital L, right, on the same line. So I'm talking about the proof for that. See, when you are writing any sequence or signal, right, if you are saying xn, what you write? X of 0, what it is actually? 0th instance, right, comma, I should give comma, not plus, comma. You are having first instance, then second instance, correct, and will continue, correct. This is the signal that you are having. When you are writing xz for that, correct, so we are having that summation ka formula. If I'll expand by that, x of 0, z raised to 0, so 1, x of 1, z raised to minus 1, x of 2, z raised to minus 2, and will continue definitely till infinity by definition, correct. Now if you will differentiate this, d dz of x of z, then this is constant, so it will become 0. This is x1 constant, z raised to minus 1, so minus z raised to, I'll put bracket, z raised to minus 2, correct, plus x2, wait, z दिख रहा है, x2, correct, and for this minus 2, z raised to minus 3, and definitely this thing will continue, correct. Now if you want to take something common out of it, very well, it is you can see over here that z raised to minus 1 is common, correct. So we want to take that common. Now why not 2, you will understand. Let me take it. So minus, one thing is minus sign is everywhere, and z raised to minus 1. So what remains inside? x1, right, minus you have taken common, so z raised to minus 1, correct, plus x2, you are having this 2 also, so I'll write into 2 into z raised to minus 2. So if we'll continue with this, x3, 3, z raised to minus 3, and will continue, correct. So what I can write? Minus z raised to minus 1. Now you just observe, this is a series, so definitely I can write it in terms of summation. N is going from 0 till infinity, correct, and n, that this number is coming to 1 over here, which you cannot see, right, xn, and z raised to minus n. See, 2, 2, 2, xn, n and minus 2. So n again z raised to minus n. Right? First term you will say 0. So 0 over here. So 0 we have not written. If you want, I'll write it 0 plus. So will be more clear. 0 plus. Okay. Okay. So now how I can write this? Minus z raised to minus 1. Correct? Very well you can understand by this that it is z transform of n xn. जैसे यहाँ पे किया हमने, right? We have taken this inside. Same thing you are having n zn, correct? So I'll write this is z transform of n xn, because this is z raised to minus n. So by definition you are having z transform for this. Correct. Now what you are having? If I'll take this z in the denominator, in the denominator, z raised to minus 1, it will go in the numerator, and you are going to have minus z d dz of xz is equal to now z transform of n x of n. So you just see the statement. Right? When it is just xn, you write xz. But when it is n multiplied by xn, then it becomes minus z d dz of x of n. When we'll use these formulas, more in clear you will. Just we are trying to prepare the theoretical part now. And the last one. Just a final value theorem we had for, if you can remember, for in S domain, right? What we used to write? Final value theorem, limit t tending to infinity f of t is equal to limit s tending to 0 s f of s. If you can remember, error may we have done this, correct? On the same line. Final value theorem over here. Final value theorem says limit k tending to infinity f of k is equal to limit z tending to 1 z minus 1 f of z. You are not having in all these things in depth. इतना depth में you are not supposed to solve anything, but at least if the thing is asked to you that what is the formula, what are the properties, you should be able to understand. Okay. Yeah. Now the next thing is some more numericals we want to solve. So we'll go for that in the next lecture.